Hi, good morning, people. Again, hope you have enjoyed your off day yesterday. According to me, we are still busy. We finished the chapter about temperatures. Is there any questions of anybody who have still a question for me regarding temperatures? But otherwise, we can start with the energy subject today. Chapter today. Anybody? I can't remember if I've asked you to do something with all those holidays. I can't remember all the things. But okay, if there's nothing, let me continue with energy. And I've asked you to run through that. I can't remember. But first, before we go into the slides, let me first talk about it. Okay, according to me, also today is your day, but the last day to hand in your assignment. If you have already done the assignment, I think one of the questions was about energy. Okay, there will be three conditions, and that's the most important one. The first one, okay, but before we start by the conditions, what we will do is we will have a piece of metal but hanging like here with a collar here, with a collar. And then what we will do is we will put a weight on it, and inside here we will work out what is the energy, what is the change in length, what's the maximum stress, all that type of things. We also will have part what have more than one size on the material, but we have two materials, but also again with my weight here. This is what we will do, and in the two materials we will calculate what is the energy there, what's the change in length, and all that type of things. All right. To come back to that, there is three conditions. The one condition is gradually applied. That means from the end of the day, gradually applied is the one where I have what I draw for you the first time here. I have that, and I put on a load here. Okay. With my load, yes, there will be change in my length. There will be a change in my length, depend on my weight here. But if I remove my weight, automatically my length here will go back to its original length. This is where, when you remember the first chapter, you have that graph there, your stress strain graph. It means you're working with the part here. And also, people, what is important in this case here, if people do not indicate to you what is Young's modulus, we do not know Young's modulus, then also when it is gradually applied, I can calculate Young's modulus also. And we'll show you later on in a problem how it works, but then you will also, and then on the end of the day, with this part here, is what you have done the first chapter, stretch equals to force over area. That is gradually applied in this case. And when you put it down here, then automatically you will say it's a tensile one. That's the first one there. The second one, what we will do is when I again my part, I pick my load up a certain height and I let fall it down. Automatically, it directly indicates you it will be impact load, right? Or shock load, depend on whether some books it's impact, other books that is. So that is my second condition. And when it's falling down here, automatically with my graph here, the chances is good that they're going over the elastic part and they're going to more to a maximum one there. Right. And we will come later to a formula, because here is different. It's kinetic energy and strain energy is involved here, but we will come now when we're coming to the slides, when you will see where everything came from. Right. And then the last one is the one again where you have it your load here, but I do not pick it up. My height is now 0. I do not pick it up. But because the weight is so heavy, when I release the weight, then there will be also a change there. Do not going back to its original length. It means it's also somewhere there. And that one we call saddily applied. Right. That means you have 3 conditions: gradually applied, impact load, saddily applied. And I've also, I think every one of you know now, because I asked you in the assignment to explain it to me. Hopefully you know all the definitions and things of it. Right, let's be going to the slides. If there's any questions, you must stop me, please. Right, I hope you have working through the slides also last night. I hope so. All right. Strain energy, and what I indicate to you that we will working in a type of a rod. It can be round, square, it can be a pipe, everything like that. Okay. Things what you already know. You know how to calculate Young's modulus. I think you know how to calculate stresses. You know what is potential energy and what is kinetic energy. That everything you have done already on school, and you are supposed to do that also in first few weeks in mechanics. The outcome is what I already try and explain to you. We will decide now between look into the difference between gradually applied, impact load, and saddily applied. You will have also, we will come now to the formulas and things. We'll show you how to get the formulas. And then also the modulus of resistant materials. And then the thing is to derive the formula. And you will see people, sometimes there is more than one formula, but I will explain to you what is the difference between the 2 formulas as well. Okay, that is what you have already done. I hopefully on school that you let me get my pen here. When you have your load here coming down here with load, we know there is change, and you know when with your graph your force to your change, everywhere you will be the same. You have your straight line, what we call also your strain energy. Right. Important is strain energy is a U, and the unit is joules, J. Right. That is also important. But you can work through all the slides. I think I do not want to read everything for you. All right. That you can go through. Okay, as I tried to say to you earlier, when you have a gradually applied part, it means that you have a load apply a way that the load increase from 0 to P. That means you make it bigger and bigger and bigger. But the main thing here is when you release the load, it goes back to its original length. And this is the one what we call gradually applied. This is what you have done in the beginning of the year. Stress equals to force over area. Straightforward. No difference there. When you come to the gradually applied load, what I tried to explain to you earlier, some books also call it dead load. Check for that also for that word. It's also called dead load. That means I want to prove now for you the formula against your load and your change. Remember, people, there must be a load, there must be a change to get strain, and out of that strain is also energy. There's energy in the material to change. Okay. Now, if you're looking in here for your load to your change in length on my triangle here, can you directly say half base times height? Now, my base in this case is my change in length, and my height is my load. directly when to calculate my strain on the end of the day, can I say it is half load times change in length. And remember here, important is, this formula here is when you have one, what I show you now, it is a single one. It's not a double one. That one we come later to when it is in theory. It's only a single one with a load down there. All right. Then also what you can say is in your change of length, what you have already learned in the beginning of the semester is stress L over E. And you can also say it's P square over LE. That means if you have a load, you can directly use this formula and say my strain energy equals to my load square, multiply my original length, divide by 2 times my area and Young's modulus. That is your first one when you want to calculate your energy in a single one when it is dead loads. All right. From there also, can we continue and say when you the strain energy multiplied by the volume of the material, and then you can say on the end of the day, my part is here, because there must be volume to have a strain on the end of the day. And that is important. You can also hear the previous one, what I show you here, you can also use this one and only multiply by my volume also. No problem, you can do that as well. But depend on if you know the load or you know the stress, or maybe what he asks you. If he asks you to calculate the stress, then straightforward to use that one, because he will tell you when what is the load. All right. Okay, that is only the models. You can go through that. That is the same here. All right, now the next one is the impact load. But when you come to the impact load, important is there will be now a change. What he show you here, the change what he show you here, and that change there is because of my weight what falling down, and the chances is about 99%, but he will not go back to his original. And that is impact load. But it means he drop a load onto the body from a certain height. That is very, very important. Now, what important is here, what you have already learned on school, if you have something like this, your potential energy is equal to your strain energy. Because of that load of the impact, there will be potential energy because they will have a change, and because of that change will be there a strain energy. But that too must be equal, because if it's not equal, then what will happen? That load will continue changing, and that in real life it cannot happen like this. All right, that means for my potential energy, that formula I think you guys know, I hope so. It is your load multiply the height what is falling and my change. Remember my change now is stress L over E or L over AE multiplied by my strain and my energy. Right, and there, okay, they indicate you what is your change in length. Okay, right, remember people, this is what you will see when I done there's other formula also now I will show you now. But when I done my calculations for impact load, I use always this formula. Always I use this formula. There is our one now. We come now to that one, and we'll explain to you what is the difference between the two. But when I done the problems, you will see when we done problems now, I will use this one all the time. Okay. Now, important is, if my change is very, very small, and I do not like this comment that you guys is very, very small, you can throw it away. Because in the industry, nothing is very small. Be honest with you, nothing is very small. But if it's very, very small, okay, then we can say that is more or less equals to this, but I do not like this and things. Right. Now, important is, if you're going back to the previous equation, where is it now? Question 7. Sorry, then this part here, the previous one, this one here, I'll say only L time for my volume there. And I want to show you now something. And that is a proof of a formula. You can work through it. We end of the day, you start here and calculate for your stresses here. And when you're going through to do a quadrant, you come through here and you come out by this formula. This formula here. People, this formula can you also use to calculate the maximum stress. But listen carefully what I said today to you. If you want to use this formula, use it for a single one. When we come now later to the ones, what is not single, what is more than one load, if you use this one, you will not get the right answer. My other question is, if in this problem now here, I ask you, calculate for me the height. I hope you know your mathematics is good and you will get it quickly out here. The reason why I say that, if we're going back to the previous one, can you see here, if I want the height here, I think it is straightforward. But I pick up when people use this one here, and I ask you to calculate the height of something under the square root, there is problems. That's why you can make the decision. You will pick up, I never use this one. I never use this formula. I always using, for impact load, I using this one. This is the one what I use. But it's up to you. You can use what you want to use. If you get the right answer and your mathematics is 100% correct, I have no problem. All right. Okay, and then, okay, for your change, stress L over E, or you can say that's also equals to PL over AE, if I'm right. Okay, right. Now the next one is suddenly applied. Now, in this case, of some books call it life loads. I think what is important here is by height, there's no height. Remember what I said to you earlier? I put it down and see if there's a change. That's why, again, its potential energy is equals to my strain energy. But my height is 0. That's why it's falling away here. All right. When you've done all the substantiations and things and calculating things, then you come out that your stress is equals to 2 times P over A. 2 times the force divided by the area. And people, again, this part of my area is my cross-section area. Right, that is important. My cross-section area. Okay. Right, that is the three, on the end of the day, the three formulas. Before we continue to example, let we go back. Well, no. That means, now can we say, to sum it up, when you have gradually applied, stress is equals to my force over area. Inverse, make it a little bit bigger for you guys. Inverse here, can I also calculate Young's modulus if it's not a given part in the question? I can still use gradually applied to calculate Young's modulus also. And the reason is because we are in the first part of my stress strain graph. The next one is suddenly applied, where we know the force is 2 times my force over area. That is.
Sorry, sir.
Yes.
So I just want to know, for the gradually applied loads, are we allowed to assume the Young's modulus instead of having to calculate it?
No, you cannot assume. If I do not give it to you, then there's a reason for you when you must calculate it.
Okay, sir.
You never assume. No, never assume. But I don't know if that problem is in your tutorials. I will check. Otherwise, I have one where I will show you an example where we will do not have Young's modulus and how to calculate. I have examples somewhere. I'm only looking for it. Right. Then the other one is my impact load. That's where I say my potential energy is equals to my strain energy. Right. That is the three formulas for you to know now. Now, in the case, we will come now to a part when we have more than one. I will go through it now as well. But, for example, if you have one like this, and you have a load here, and I ask you to calculate the maximum stress. Right. Now, to calculate the maximum stress, that one is an impact load because I lift that thing a certain height. So that is number one, which is number two. And I think what you have already learned, you will tell me that my maximum stress will be in number two. I'm right? Everyone agree with that? My maximum stress is in number two. Everyone agree with me?
Yes, sir.
Right. And one guy agrees with me. I hope the rest is also happy. Now, when I come to that, I will say my load, height plus, remember now with my potential one, the change there, with this load, there will be a change here and there will be a change here. But the change here and the change here will not be the same. That means I will have a mechanical change in number one plus a mechanical change in number two. Will be equals to. Now, there will be strain energy number one and there will be strain energy number two. But the size of the area is different. That means my strain energy in number one will be different. That means the strain energy to E in number two. That means there's my formula now. Now again, we know this X is equals to stress L over E. That we know. Now again, there will be two unknowns because there's a stress 1 and a stress 2. But we know I said to you, I want the maximum one. It means I want stress 2. Now, because I have two unknowns, now I must start looking for what you have learned on school. If you must calculate X and Y in mathematics, you must have two equations. But directly can I say, because this one here is that my change here, my mechanical change in number one and number two is not equal. That is different. We cannot say that is equal. That will be different. But this load is working to this one and to this one. That I can say my force in number one is equal to my force in number two. And out of this one here, can I get now a ratio? Number one is equal to something, number two, and I can put it or sub it in there, and I can calculate my part. Now, can you now see if I talking about this and I go back to the previous part, we will have that other formula. Let me get quickly that formula. That other formula. That one, stress is equals to, let me get that 1 plus minus 1 plus 2A HE over PL squared. Now, people, if you're looking into this one now here, that formula here, and I said to you calculate the maximum one, how can you use this one to calculate the maximum one if it's there? Yes, if it was a single one, if it was only a single one with a load. Then I can say, okay, you can use this one. You can do maximum stress for maximum stress. But if you have something like this, please do not try and use this formula. You will not get the right answer. I will guarantee you that. I will guarantee you that. Right, everyone with me. That is what is important here. But we will continue now on the slides to the rest of a part of the work. Right. Okay, then I do not want to work through all this. There is examples for you also on the slides what can help you. Please work through it. That one is a straightforward one. You say you have 25 rods, 6 meters long, maximum weight is 20 kilo. Calculate the load is applied, Saturday applied, and with the weight falling. That is what we have done there. If you look into the part there, the first part is where you say the first part is for gradient applied. I calculate my stress there straightforward. The second one is I can only go and say that stress multiplied by 2, and I get my answer for Saturday applied one. When you come to the impact load, see the guys use that formula. You get 2 answers, and then you make a decision which one is the right one. But if you use only the other one, you automatically will see which one is the right one. Right, but we're also doing some problems. Then there's example number 2, but you can work through. People, I do not work through all that type of things. It's important. You will see there is one like this also in your tutorials out of the Wiley Plus book also where to use this. There's also for example regarding this when your kinetic energy is equals to your strain energy. Okay, when you have velocity. Okay. Then there's another one where you can go and you can use all that. I do not want to run through all that. All right. Now important is what I already tried to explain to you. When you have your rod, what is in theory, it means when my forces are equal and my change is a change in number 1 plus the change in number 2. This is when it is in theory. That is very important. When you have your rods, what is in parallel, then again, and here's a mistake here, then again you will say your force in number 1 is plus force in number 2 is my total force. You remember we have done also that in the exam in the temperatures as well. But here my final change is equals to my change in 1, and that is wrong, is equals to the change in number 2. This is what we have done already previously. All right. And then to go further on the things, he said to you, if your strain energy for rod what is in series and parallel is versus the case here, what I already showed you earlier, that you have your strain energy in both of the materials. All right. And then there's examples again for you. You can work through all those examples. I want us to do our own example because those things you can look through. All right. That one is more or less what is in your syllabi for this part of the work. Right, I start out with the tutorials, looking for a problem for us, and let me then start and work together on a problem, and then I will also give you another one also later on. Let me check. Is there any questions up to this point here? Anybody have a question? Right, people, out of the tutorials, there is, I think, 10 problems for you. I said again, if you can do all those problems, I do not think you will struggle. All right, but let looking which one we can do now. Let me start at alphabet tutorials. Let me let you are quickly doing number 6. Yes, number 6. If you remember the tutorials, you say the suddenly applied load stores 2 joules of strain energy in a 300 millimeter long aluminium bar with a with a 50 millimeter square cross section. Calculate the maximum stress induced in the bar. Right, straightforward. There's nothing difficult there, but we know my is equals to energy is equals to 2 volume over 2E, and he indicate to us that my energy is 2 joules. He want stress. He want the stress. Multiply the volume is a square. It is 30 by 300. Divide by 2 times Young's modulus in this case is 70 times 10.9. Right, quickly calculate for me and tell me what is the stress. Come, everyone.
Sorry, sir.
Yes.
The product between the stress and the volume, is that supposed to be 0.03 cubed? Because I see that you wrote 0.03 at the end there.
You happy now?
Okay, yes, sir. Thank you.
Hey, good. Looks like you are the only one who's not fast asleep. Other guys still struggle with the bubbles of yesterday. Hi, people. Anybody have an answer for me on this one?
So I get 32.20 megapascals.
Something like that?
Yes, sir.
100% correct. Right, yeah, that one was straightforward. I think that is maybe too easy for you guys. Right, let me moving to the next one. What I want to do with you guys is problem number 7. And people, please, I want everyone to work with us. Out of the tutorials, problem number 7. That was number 6. Problem 7. Right, for the guys who do not have it already printed, you say to you, you have a load of 10 kilonewtons hang from an end of a 12 millimeter diameter steel rod. If the length of a rod is 500, okay, that means you have single rod here. Single rod. Say this diameter is 12 millimeters. Also say to you, is a weight here of 10 kilonewtons, and it also indicate you that the total length is 500 millimeters. People remember when I talk about the length, it's the length of this rod. The collar is not included. The collar is only there, but the weight cannot fall right through. Right. The first question say the maximum stress induced in the rod. Okay, calculate the maximum stress induced in the rod due to a gradually applied of 10 over 10 kilometer. That means you want it gradually applied. Right. Now directly we know 7.1 that my stress is equals to my force over area. That is for gradually applied. And then you say your force is 10 times 10 to the power 3 divided by pi over 4, 12, 0.012 square. And that is equals to
88.42 megapixels.
right. I hope everyone's happy with that. When you come to point now 7.2, I will give you a little bit of time to see if you can do it yourself. You say calculate the maximum of a rod, of a diameter of a rod, if a 10 kilonewton load has been suddenly applied and the maximum load stress was limited to 100 megapascals. Right. Quickly, try and done that one for me. Let me see if I have an answer. Anybody of you have maybe an answer for me? Right. One thing what we know in the case here for 7.2, we know the formula says for suddenly applied is 2 times the force over the area. And you want the D.
So what's the maximum stress?
Come again?
The given maximum stress.
Yes, you say to you the maximum stress is 100 megapascals. And you want the diameter. If a stress, if it's suddenly applied, and the maximum stress is 100 with that load of 10 kilonewton, what is the diameter of that rod supposed to be? Some people do not want only one guy to talk the whole time. I want other guys also. I want the answer from other people as well.
Sir,
Yes.
I think I got 15.96 millimeter.
15.96 millimeters. Anybody have a question on this one?
So I got 0.016 meter.
Yeah, but you must put it in millimeter. What
I
is
want
it
it in
in?
millimeters.
Yeah, it must be in millimeters. People
Oh,
remember,
16
yeah,
16 millimeters.
you see, you round off. 15.9, 15.96 is 100% correct. If you say to me 16, I will mark it wrong. It's not 16. Please, people, 2 decimals after the comma. That's important. Make sure. All right. Then the 7.3, you say now you want the maximum height from which that 10 kilonewton load would have fall down onto that steel rod if a maximum stress is not more than 220. Right. Now I pick it up in my part here. I will pick this thing now up a certain height. And I let fall it down to my collar, and my maximum stress is equals to what, 220 megapascals. Right. Okay. Right. Quickly see if you can calculate that for me. The maximum height, you will pick it up. Right, in this case of 7.3, you will say your weight plus height plus multiply height plus mechanical change equals to my strain, what is 2 volume over 2E, and D1 for height. Right. With your maximum stress of 220 megapascals. Right, anybody for me answer, people? Some people cannot take you so long. Mas can complete these problems in 20 minutes, the whole problem. Come, is there anybody have an answer for me? I think people are supposed to have answers now already.
No, please have the length of the rod again.
Come again? The length of a rod.
Yes.
The length of a rod is 500 millimeters.
I get 2.72 million.
Come again? Come again?
2.72.
2.72 millimeters.
Hmm.
All right, there's one answer, people. Is that answer correct? Come, anybody?
So I use the very same formula, but my answer it's large, so I don't think it's correct.
No. Tell me what's your answer. Tell me what your
It's very large.
No, tell me what your answer.
It's my mathematics. Maybe I did a mistake. because it's too large.
What is too large?
It's like
20
there at
kilo,
Nano.
20 kilometers.
No, it's there at Nano. So I think I made a mistake somewhere.
Okay, all right. Anybody else? People?
Sir, I got 37.3 millimeters.
37.3 millimeters. Right. Anybody else? Come, anybody? Must I start calling names? Some people.
Oh,
Mr. Meneer,
Yes.
kan ek maar vra meneer, where do you take the volumes?
The volume. The volume
Yes,
of the volume of my rod is my area of my cross section area. What is 12 diameter is 12 millimeters, and my length is 500 millimeters.
Oh, okay, thank you, sir. Thank you.
If you have your force, your force is 10. I want for height. For my mechanical chains is 220 times 10 to the power 6 times the length is 5 divided by what is Young's modulus 200 10 to the power 9 equals to my stress is 220 times 10 to the power 6 square over 2 times 200 times 10 to the power 9 multiply pi over 4 0.012 square multiply 0.5. And now we're looking for the height. Looking for the height. Come people. Anybody for me answer for the height? And I want it in millimeters.
So I got
Yes.
0.134 millimeters.
Come again?
0.134 millimeters.
Thank you. At last. Right. There's the answer. You will see in your tutorials the answer is wrong in the tutorials. Because I also pick it now up while looking into it. I don't know why in my solution I used 207 for that. That means that one is 0.1342. Right. Then the last one we say to you, calculate the change in the rod from 3.7. That means I want my mechanical change in my rod, and it is on end of the day it's this part. Okay, that part. And what is that answer? That's my change in rod. And what is that answer? In millimeters. It's equals to what?
0.5 0.55.
0.55 millimeters. Right. See, people, this chapter is a straightforward chapter, but there's a lot of calculations and things. And this is where the people sometimes make mistakes. All right. Before I will give you the other problem, what I want you to do is at this point here, let me see how many of you guys is in the class today. All right, we are what? 24. Okay, more than 50%. Or 50%, yes. Our semester test must be on temperatures and this chapter. Our time is start running out now. When do you want to have your test? Next week or the week after next week? Okay, let me first, I think the best will be if we have a test on a Thursday morning, 8 o'clock. What do you guys think? Because 8 o'clock and then after, because if it's on a Wednesday 1 o'clock, when I know you guys will do not attend the other classes because you will say you're busy studying for my test. Do you think a good time is on a Thursday morning? Yes or no?
Yes, sir.
Okay, right. It looks
So,
like yes.
A class test or semester?
No, semester test. Face to face on campus.
Next week.
No, okay. There's a suggestion next week Thursday. Is everyone happy?
So I
No,
don't think that was a
I was just
suggestion. That was
asking.
more a question.
More of a question. I was asking if
No,
it's next week.
I didn't say next week. I asked your guys. When did you want to write?
That other week, so the week after next week.
The week after next week.
Yes, so we can finish the chapter during next week.
That means we talk about the 12th.
Yes, somewhere there.
Yes, sir.
Right.
Yes, sir.
Is everyone happy about the 12th?
No.
Why?
Yes.
Why you say no?
We're having something on that week. We're writing a semester test.
Of which subject?
Let me confirm first.
Huh?
We're writing
Is there anything?
a past probability and statistic test on that same day.
Yeah,
What's
we're
up?
having something on that day.
A possibility.
Probability and statistics.
Is it definitely already scheduled for that day?
Yes, sir. Class test 2.
Okay, all right. That means then that is out. Because I do not want to run further because I'm okay. The predicate day. When we check when's the predicate day. The predicate day is the 23rd. Yeah, see, when we start running into problems, if we wait till the 19th, because I want you guys to look through your test before I put on the marks. We must discuss it. And when you say to me is next week Thursday. Because otherwise we must do it when that Thursday, but I do not want it also that Thursday the 11th, because that is now a day before your other test of statics. Come people, come with a
Sir?
suggestion, yes.
What about the Tuesday, the 10th of May? in the practical period.
Practical
Yeah, that
period.
might work, sir. I second that option. I second.
But okay, tell me what time is, because it's not on my. I must check my schedule also now because it's not on my part because I haven't the practical. What time was your practicals?
Practicals is from 4 to 5:45.
Okay, I'm not available on that time. I'm not available. That can't work, and that is after 4 when you guys complain about transport. That's your other problem. Let me see.
We used to attend. It's going to be fine.
What?
Or say
Oh, no.
Friday.
For the practical session.
No. I'm not available.
Oh,
Sir,
Yes.
Friday after so 1 o'clock, are you like busy? Because I think at that time we have a free time there.
Come
right on Friday.
Okay, come again. What do you say now? I can't hear you clearly.
Friday.
Friday.
From 1 o'clock, we're free. We don't have any classes. Hey.
From 1 o'clock on a Friday.
Yes, 1 o'clock. Yes.
All right, but now we're talking about which Friday? I will also check my Friday. The 6th, Friday the 6th. I'm not available. Then I'm not here. Then the other one is the 13th, but that is a day after your static test. Then you complain again and say you haven't enough time to study.
And the Friday the 13th with writing design of machine semester test 2.
Okay, then that's out. That's out.
It's Chai next week, sir. It's Chai. You can see yourself.
Right. What do you guys say now? Next week, the 5th, Thursday.
Yes, so it seems to be the only option.
Yes.
Yeah, because the work is not a lot of work to do. If you can do that 10 in each chapter, that 10 tutorials, then you're supposed to get 100%. I will not ask you that question, but it's more or less that's only the way we can ask the question. There's no other way we can ask it. All right, then I will put on D2L later today, when we will make it the 5th. But that's the only time what I see now here. Where did I go back? There's the test. Because I do not want your guys that you guys have enough time to study. I think you have already enough time to study. You guys didn't study. That's my problem.
Okay.
All right, people, and I tell you now, your test will be 1 hour. It's 2 questions, one of temperatures, one of verse 1. And I make it 1 hour because give you 30 minutes for each one. That's why when you practice the things, make sure that you use less than 30, because in the exam, I have already set up the exam question paper. In the exam, is I think 7 questions for you. And you can work it out. That means you must, for 3 hours, you must be about 20 minutes on each one. And that's why try your best to do those problems in about 20 minutes. You will see when we've done the last chapter of a sexy moment of areas with that blue book, that can take you about more than half an hour to do. And that is the one who has always a lot of marks in the exam and things. And we will not have time to have a test on that one. That's why this semester, now the other thing is what we also must discuss. Prof. Desai also indicated to me, I think with his test, there was 5 guys who missed the test. Because we must also schedule a sick test also, but that I will check here and I will schedule, but I know there's already 5. But Prof. Desai asked me if we set up a sick test, but that 5 guys can also sit for the sick test. I know there's 5. I will get the names from Prof. Desai. And if any one of you missed this test next week, Thursday, it means you will sit for the sick test if you have a sick note. And I warn you now, the sick test what I will do is I will looking for old exam question paper. All the work from Prof. Desai, all my work, include the chapter what we have not yet done. It's included. Everything. If you miss a test, the SIG test in this department is all the work. Everything. I warn you. Please make sure that you sit for my test. Otherwise, you will say there's already 5, what I understand. And if that 5 people, if you miss and my test, it means for one of the tests you will get 0. The SIG test is only for place 1. And the SIG test is not a makeup test. That means do not come to me and say, yeah, but I have done badly with Prof. Desai in his test, or with my test, your test now, I done very well. Can I sit for the SIG test? No, you cannot. It's only, I clearly to you, it's a SIG test, not a makeup test. People come with this words of makeup tests and things. For me, makeup is what ladies use to look, my faces looking good. All right, okay. That means I will schedule that, and then I also will decide today when is the SIG test, and I will put that also there on for you. From my side, the last problem from this chapter, here's the problem. Let me turn it like this and see if I can make it much bigger for you. And I want you to start work on this problem. And I will not give you the answer and things today. That's one of your homework problems for next week. What we call it, next week Wednesday. That when we will finish this chapter before the test. And this is the one where I said to you now, the hint here is he did not indicate to you what is Young's modulus. It means you must calculate Young's modulus out of this problem. And you will see it's a combination now here. It's a combination. And please, people, try this problem. There's only 1 or 2 guys who working at this stage in this class. Look at for me. Please try the problem. That's important. That is one of your homework problems. The rest is all the other problems in the tutorials. And we will first, and remember me, and not forgot to show you the answer of this one, because you can maybe see something like this in the exam, who knows, or in the test. Remember me that I forgot to show you the solution of this one, and then the rest of the class time will be open for you to ask me any questions out of temperatures or out of this chapter, what we say, strain energy. And then after that one, we have 1 chapter left. That is a section moment of area. That week after that, we will start with that. What I will do is I will try and finish marking your test before that next week. Your test will be then available here in my office, or here in the front office. I will inform you when it is available. You can come and collect it, that you have your test with you the day when we discuss the question paper, and then you can make sure that you know where was your mistakes, if you have any mistakes, or maybe you have 100%. You're supposed to get 100%. Right. That means, please, people, that is the problem what I want you to do for me for next week and Wednesday. I will now on D2L put on the test dates and things. There's no venue yet. I will send through now to the administrators what I want, and then the people will indicate us what is the venue, and then I will inform directly. When I know what's the venue, I will inform you which venue will be your test be. Right. Any questions from anybody before I say goodbye? Everyone happy? Right, it's quiet. I hear nothing. It means everyone is happy. Let me stop the recording. People, when I